Okay, so for this problem, you are figuring out values of theta that make this equation true. And the first thing you need to notice is that this equation is already in a factored form. So what you're going to do is set each factor equal to 0. So you're using the zero product property that you probably learned when you learned quadratics. But basically, each factor could be equal to 0 in order to make this equation equal to 0. So we have cosine theta equals 0, and then on the flip side, we have tan theta minus radical 3 equals 0. So we'll start with cosine theta equals 0. So on the unit circle, you're looking for where cosine is 0. And if you can remember, cosine is represented by the x-coordinate. So the x-coordinate would be 0 when we get to the top of the unit circle and when we get to the bottom, because that's when the x value is 0. So that happens when theta is 90 degrees, and again when theta is 270 degrees, or if you're in radians, which you might be, theta is either pi over 2, which is the equivalent of 90 degrees, or 3 pi over 2. And the way you could get that if you're not sure is that pi radians is 180 degrees, so you can set up a proportion, and so you would figure out x over 90, and basically multiplying both sides by 90, you would get 90 pi over 180 equals x, which then that reduces to pi over 2. Both numerator and denominator are divisible by 90, so you could do the same thing for 270. For the second one, tangent theta minus radical 3 equals 0. The first thing you do is add the square root of 3 to both sides, and we are getting tan theta equals square root of 3. So in terms of the unit circle now, you have to look at a ratio of sine and cosine. So tangent is sine over cosine. So I'm going to write that here, which in terms of the unit circle means that tangent will be the y-coordinate over the x-coordinate. So we're looking for, and I'm just going to start with quadrant 1, where everything is positive. We're looking for a place on the unit circle where when I take the y-coordinate divided by the x-coordinate, I get square root of 3. So listing what's going on here, we have that this coordinate is radical 3 over 2 and 1/2. This coordinate is radical 2 over 2, radical 2 over 2, and right here we have 1/2 radical 3 over 2. Notice the y-coordinates are getting bigger and the x-coordinates get smaller because we're getting closer and closer to the y-axis. So when you divide these two, the over 2 part really won't matter. It'll cancel itself out. So we're looking for the one that is radical 3 over 1, which happens here at 60 degrees. So I have that theta could be 60 degrees. And now there's a second answer for tangent where tangent is also positive. So one phrase I usually teach is that all students take calculus. And this tells you which quadrant or which trig function is positive in each quadrant. So in this quadrant 1, all of the trig functions are positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. So we're looking for an equivalent place here in quadrant 3, which to get all the way to here, I'm going 180 plus another 60. So the other answer would be 240 degrees. And in terms of radians, theta is pi over 3, and you can count pi over 3's around the unit circle. So you get 1 pi over 3 here, 2 pi over 3 there, 3 pi over 3, 4 pi over 3. So the other answer would be 4 pi over 3. And if you know that 60 degrees is pi over 3, then 240 is 4 of those. And that's it.